Alright, so in this video we're going to just look over some function notation. So here we have an example of a function f of x equals 2x squared plus 3x plus 5, and we're going to just practice using various inputs and operations with functions. So the thing to remember how functions work, so this is basically saying that x is the input, so for whatever input I use, I'm going to take 2 times the input squared plus 3 times the input plus 5. So when they're just basic numbers, this is really not a big deal. F of 2 would be 2 times 2 squared plus 3 times 2 plus 5, and then order of operations from here. So this is 2 times 4 plus 6 plus 5, and that is 8 plus 6, which is 14, plus 5 is 19. And there we go. F of negative 3, same thing. I just want to be able to practice with working with negative numbers, since those sometimes can be a little bit tricky. So we just plug in negative 3 for x. Notice I'm putting negative 3 in parentheses, so we know exactly what the input is. Negative 3 squared is 9. And that's plus negative 9 plus 5. 2 times 9 is 18. 18 minus 9 is 9, plus 5 is 14. So there we go. Okay, now f of 3m. Now again, same idea. We're going to take 2 times the input squared plus 3 times the input plus 5. So I'm going to put in 3m for the input, and then let the problem tell me what to do. So here it looks like 2 times 3m squared. Well, 3m quantity squared is 9m squared. 3 times 3m is 9m plus 5, and this looks like 18m squared plus 9m plus 5. Okay, so hopefully this is straightforward so far. Now we'll talk about plugging in something a little more complicated in a different way. And again, using the same principle, well, I kind of meant to do that and not meant to do that. So just remember, it's 2 times whatever squared plus 3 times whatever plus 5. So I'm plugging in x plus 1 for the whatever. Now here, it just takes a little bit more effort to multiply out x plus 1 squared. But remember, the 2's outside, so we have to square first. And once you square that, you get x squared plus 2x plus 1, whether you use FOIL or whatever. So this is 3x plus 3 plus 5. So this turns into 4x squared. Whoops, not 4, sorry. 2x squared plus 4x plus 2 plus 3x plus, I can combine 3 and 5 to give me 8. We should always combine like terms when we can. This is 2x squared plus 7x plus 10. And in our last example, we're subtracting 2 function values. So basically, if I know what this is and know what this is, this problem is just telling me to subtract them. Well, luckily, we know that f of x plus 1 is 2x squared plus 7x plus 10. And we know that f of x was given as 2x squared plus 3x plus 5. Now, the thing to be really careful about here is, remember that when you're subtracting something, you want to make sure you're subtracting the whole thing. So we're subtracting in parentheses, which in this case means I'm going to have to distribute the negative through. So that's going to mean 2x squared plus 7x plus 10 minus 2x squared minus 3x minus 5, and then combine like terms. The 2x squared goes away. 7x minus 3x is 4x. 10 minus 5 is 5. So that is the expression for f of x plus 1 minus f of x. And if you're wondering what kind of expression that is, that's basically telling me the output at 1 more than the x value minus the output at the x value. So we're going to be using this a lot with cost, revenue, and profit functions to determine, for example, at a given production level, what is the cost of producing the next unit? That's kind of what this expression is going to be about. So as we look through some applications, we'll actually explore that. So that's some function notation for you. Thank you for watching, and I hope that function notation makes a little bit more sense than it did before. So thanks again.